Welcome back, everyone, to episode 3 of Token Engineering Public Goods, a new educational interview series focused on education and exploration within this emerging field of engineering. My name is Nate, and today I'm very excited to welcome Rohan and Angela. We will be discussing LLMs, cadCAD models, and a new product being developed, cadCAD GPT. Before we get started, I wanted to say that this episode is hosted by the Token Engineering Commons, a community of token engineers dedicated to funding the provision of token engineering public goods. A quick message to our audience before we begin. If you are listening to this interview and you see that I missed an obvious question or you're curious to know more, we will have a few minutes after the interview to ask our guests some questions, so please don't hesitate to raise your hand and we can bring you up on stage. With that being said, Angela and Rohan, welcome. So glad to have you here. How's it going?
Hi, everyone. Thanks for having us today. Glad to be here.
Hi, guys.
Yeah, and perhaps we can start by introducing who you are, how you got into the Web3 space, and a little bit about your current efforts in the token engineering world.
Do you want to go first, Angela?
Okay, thanks. I'm Angela. I'm the founder of Token Engineering Academy. I'm in this space, token engineering, basically since 2018, and my first steps in the blockchain world were in 2016. Back then, I was in early stage startups, investors, as well as the startup sites for quite a while. So I know digital products in Web 2 quite well. And when I came across tokens and what we are able to, the design space of token economies, incentive design, this just blew my mind because it's so much wider than what we know from Web 2. And I met some really interesting people back then working on white papers and on some first mechanisms like the bonding curve. And this got me hooked. In 2020, we decided to start the Token Engineering Academy because this combination of computer science, cryptography, mechanism design, game theory, and also systems engineering, and then the governance part is a combination you can't study nowhere on no university on this planet. And we were so frustrated, so to say, that we decided, okay, so let's build our own courses the way we think. What should we teach or what should be learned in this sector, put together an own curriculum, and also how to teach it, how to learn it. And the result of it is TE Fundamentals, which is the first bachelor level course in token engineering. You can find it and start studying it at tokenengineering.net. It's a free online course, 5 modules, and in 1 year, 3,500 students enrolled. So this was quite successful. And cadCAD GPT is one of the initiatives we started together with TEC. I guess we get to that in a moment. And I stop here. Rohan, mic is yours.
Hi, I'm Rohan. My background is in physics, and I actually joined the space because I was really excited about quadratic funding and the Gitcoin project. When I read about it, immediately something clicked in me. I felt like these socio-technical systems are super fascinating. I thought about getting into the space via potentially learning Solidity, but I eventually very quickly realized that when I saw Michael Zagum's work on YouTube, some of his talks, I immediately reached out to him. He pointed me through the TEC, and that seemed like the perfect place for me. I joined in the first cohort of the Token Engineering Academy for TE Fundamentals. I've been a study group host there ever since. Everything that I've learned from the space has come from there. I'm still continuing the study group. It's been like more than a year right now. A year and a few months. And currently I'm a research engineer at Block Science, and I'm also the data scientist at cadCAD GPT. So let's get into it.
Yeah, this is honestly, one of my favorite parts of every interview is just learning how people got into the space and their kind of journey. Everybody has a different path and different story, and it's really beautiful to hear everybody's pathway to where they are today. But so today we're going to dive into it. We're going to learn a lot about token engineering, a lot about large language models, and how we can merge these concepts to build tools that are useful to engineers and building out new, safe, and ethical crypto economic designs. And so I was hoping, Angela, if you could start us out and explaining for those in the audience who are maybe are unfamiliar with token engineering,
Mhm.
what is the token engineering design process is, and why is it important to
Mhm.
understand?
Yeah, sure. So generally, token engineering is the design, verification, and optimization of token-based systems. And here we are designing economies. And this includes that we first of all start with collecting the requirements. So we take a look at the economy that we'd like to design, look at their stakeholders. So what's the actual value exchange here in this sector? Is the purpose of this network? This can be data storage. This can be verification of some kind. This can be NFTs. It can be reputation. We've heard Gitcoin grants. This is funding public goods, funding projects. It can be gaming. And once we take a look at the purpose, we can define what the stakeholders are and what's their motivation to participate. And from there, we can get to the goals for every particular stakeholder and then see how can we first describe their activities to derive the boundaries, the action space, and second, what incentives can we use to propel and make people do stuff, as some people call it. And once we have these requirements, and by the way, ideally, this builds on a problem solution fit or even better on a product market fit. So, meaning if what you have in mind, if the purpose is just irrelevant to users, you won't be able to just build up a successful token economy just because you have tokens. This, for example, hasn't changed compared to anything beforehand, compared to Web 2 or compared to real world products. You have to solve a problem for people. And then you can get things going and grow the network and onboard new stakeholders with tokens. Okay, once we have these requirements, we take the next step. We take a look at the algorithms we need, the incentive mechanisms. And this is the big opportunity and also the challenge for token economies because, number one, the big opportunity is we can automate everything. We can enforce, we define the rules, we design the rules of the game, so to say, and then computers take over, algorithms take over, and we enforce the rules of the system not via contracts, not via middlemen, purely because of the code. And this of course, requires a sophisticated design and verification because we not only have to see how the mechanism could work, we also have to foresee the vulnerabilities. Because once we push the start button and things get going and stakeholders start to interact, we have to be aware of these vulnerabilities. Otherwise, there could be not only code exploits, there can be economic exploits that make our systems break. So, a big part then, after the design of the algorithms, is verifying these algorithms and finding vulnerabilities, gaps, trying to improve it, try to secure it, try to see how it can get imbalanced, what are edge cases to really understand and make this algorithm, these mechanisms bulletproof before you then implement it in smart contracts. And that's roughly the process of token engineering. And the big new part here that is unusual to anything we've seen in Web 2 is this algorithm design verification part. And this is also a main goal where cadCAD GPT, a main area where cadCAD GPT supports.
Yeah, and so the token engineering design process, it kind of lays out this you know journey to understand all of the stakeholders and all the participants, the design mechanisms that are involved in creating a token economy that works. It kind of lends itself to what cadCAD is, and for the people that is designed to do. And for people who don't understand what cadCAD is, I was hoping maybe you could kind of give a brief, understanding of what an agent-based modeling system is and what it's currently being used for.
Yeah, maybe I could take this up. So basically, cadCAD is an open source Python package, and there are many packages or softwares like cadCAD that exist. I hope you guys can hear me, by the way. Yeah, okay. Yeah, so like there are many packages or softwares that exist that do what cadCAD does, which is helping us design, test, and validate complex systems. But the thing about cadCAD is first of all, it's open source. It runs on Python, so you can connect many other data science tooling on top of it. And secondly, yeah, it's specifically built for natively supporting like Monte Carlo simulations or parameter sweeps or even like the standard practices that we do to study complex systems are natively built inside it. So it's pretty easy to use it for building system designs before you actually build it out on, let's say, something like Solidity or like something on the blockchain itself. So you can actually test the system before you put it out there. You can run what if scenarios. You can run all kinds of like experiments, so that you have a much better grasp of what's going to happen under different conditions before you actually put the system out there.
Yeah, and so we have this kind of exploration of the token engineering design process, and then we have this agent-based modeling tool with cadCAD that is able to take that process and kind of formalize it in a way that allows you to understand it a little bit better. Is that correct? Like with cadCAD?
Yeah, that's a perfect placing of it. It's not only agent-based. It's also, you can do system dynamic simulations. There are all kinds of simulations you can do. Agent-based just happen to be one that are also used in our spaces. In fact, I would say that the more oftenly used thing is like a hybrid approach where you use system design and system dynamics and agent-based modeling together. But cadCAD supports all of it. Yeah.
Maybe let's take a closer look of what cadCAD GPT is actually. If we look at the simulation process, we know that we need two key elements as token engineers. Number one, we need a model of the system, because usually either in the design phase you don't have a fully fledged system. You start with verifying components of it. And second, in many cases for existing systems, let's take a look at the Ethereum economic systems with the staking element, with Ethereum minting, with the transactions, the verification, and the rewards. You have various elements of mechanisms that are interconnected, and this can get very complex. And in addition to that, we have external markets. We have the value of Ethereum. We have all the projects and applications that build on top of Ethereum. We have layer 2. So this is a lot of complexity in an existing system, and that's why you usually take a simplification of a real world system, and then you build a digital twin that focuses on the key parts that you try to verify, that you want to verify, and focuses on a particular metric or a handful of metrics that you'd like to observe. Meaning, for the Ethereum network, there were certainly loads of verification runs for the shift to staking. And there, the metrics I'm talking about could be how many staking operators we might have, what's their reward, how staking rewards might change and develop over time, and if the parameters are set in the right way. So these are typical questions you ask in the simulation process. okay, we have the digital twins, the model of a system. We have the metrics to observe. And then you start with some hypotheses, build the model, run simulation, and this can be really extensive. It's not, we are not talking about 1 or 2 simulation runs. This can lead up to hundreds of thousands of simulation runs, and this is really computational intensive. And also, I'm pretty sure you have in some way been in a process of decision making where you said, okay, let's try to find out X, the cost of something, and then take a decision. Okay, once you collected some first information, instead of this leading to an easy decision, you come across more questions. So the first let's say, insights a model is able to create might lead to even more questions. You might find a problem, or you might find, you are limited in the parameter settings. You need an additional element. And this is the iterative process we typically see in token engineering. That's simulation process, asking more questions. You then have to adapt the model, start again, run simulations again. Then you might want to compare to previous versions. You might to apply, and then this is the next level, certain optimization techniques. For Rohan was talking about Monte Carlo simulations. This is what I mean with optimization technique, where you apply a certain method to get to a result. And these are the typical tools we use in token engineering, and we also need certain information about the system. This can be a textual description, it can be technical information, it can be information about the stakeholders, it can be data on transactions. If we already have a transaction history, it can be information about external systems, data of external systems, and so on. And in the context of cadCAD GPT, we are talking about memory here. Okay, and when we started, sorry, Nate.
No, please go ahead.
When we started cadCAD GPT, this was very much driven, of course, of the amazing, mind-blowing new opportunities in LLM. So we can use natural language to do stuff, and our starting point was, oh wow, this seems so powerful. How can we bring token engineering to the next level? Could this be something that's relevant for token engineering? And of course, we explored many angles. So we tried to find out, okay, can we use it in education? Can we, imagine if we would have a library of all the token engineering knowledge, could learning token engineering be much more question and answer based? Or could we apply it to build these digital twins? Or could we, and there are numerous opportunities for applying LLMs in the token engineering sector. We've chosen a very particular part of the token engineering process, ultimately to build cadCAD GPT, which is this phase where you already have a digital twin and you start running simulations and iterate on the design. What I just said, you find something, you get an insight, but this leads to more questions, and you need to adapt the model, run the optimization techniques again and again to finally land at a certain result and have to take a decision on the system design. And we know that taking decisions in crypto land is not only one person. We have token holders, we have DAO decision making, and that makes it even more challenging to have all the information available that an educated decision needs. So we decided cadCAD GPT focuses on supporting simulations, because the humans are the ones who have a lot of questions about the system design, and LLMs can help us in a great way to make these simulations faster, to make this process faster, and support us in the computational steps.
Yeah, so would you say that largely the cadCAD GPT is largely focused on helping the iterative process for the modeling?
Exactly.
You spoke about the Monte Carlo simulations, and I can imagine, if you're running, 1,000 steps uh, and a particular model, you'd have a lot of potential learnings from that. And I assume that's the areas that you find it to be the most useful, right?
Exactly. This is exactly the step or the steps in the process where cadCAD GPT supports. And I guess we get to the details, and it's super exciting how human and machine brains merge here, and how we can take the best of it to get to better token economies.
Yeah, I would even add
Yeah,
that there are
and
actually two potential users, like two kinds of potential users. One is someone who's building the model and trying to test it and iterating on the model itself. And there's another user that we can imagine, that's someone like an entrepreneur, or like who doesn't really know Python, doesn't really want to like get into the, doesn't know the details of how the model is built, how to run cadCAD, etc. But they just want to ask questions of the model, in the sense that what would happen if this was the case? What would happen if that was the case? If those are the kinds of questions you have for a system, cadCAD GPT can again help a lot, because it takes away the complexity of running Python code within your model. You just have to ask a natural language question, and you get your graphs and answers, everything that you need. Yeah.
Yeah, and I think this is something that I'm really fascinated about cadCAD GPT, is that, for the longest time, watching cadCAD slowly being developed and kind of being this fundamental tool within the token engineering space, but it's not being utilized as much, is that, having a tool such as this may be kind of a catalyst of lowering the barrier to access. And I'm wondering if, like, is this something that is on your mind when you're building out this cadCAD GPT product?
Yeah, 100%. We know that for taking decisions on a token design, you can't just rely on intuition, or you can't just rely on spreadsheet calculations, because the systems are too complex. We have dynamical systems that evolve over time. We have various system components that are intertwined. We have external factors, and this is just beyond what we can foresee. Looking at, okay, it works like this, then we probably get to an outcome like that. It's not a simple calculation anymore. So we know, for making token economies robust and fair, we need simulations. Nevertheless, this is a practice that is pretty new. I mean, it's unseen in Web 2, or very, very rare, and it's pretty new in Web 3. At the same time, we are seeing decision making develop, like in the DAOs. So we have various parties who are taking a look at the decisions to make, who try to collect information, and I think this is it's a great environment to introduce something like cadCAD GPT, because we need it, and it's also it's like simulations are a must for taking good decisions, and that's where we try to support with cadCAD GPT.
Yeah, and I think we have a good grasp of, like, that we have the token engineering design process for somebody who's interested in, like, kind of building their own token economy. They go through this process, they input their design into this kind of cadCAD model, they iterate on it, and then, the combination of these concepts with this idea of large language models. Before we get into kind of the architecture of cadCAD GPT and what it's all about, I was hoping maybe one of you could just discuss for a moment, like, what are LLMs and why are they important, and how are they being used in our context, and maybe some of the limitations of LLMs as well.
Angela, do you want to take this?
Go ahead,
No.
Rohan.
Okay. So yeah, LLMs are basically, it's interesting to see. I mean, pretty much everybody, I think, at this point knows about ChatGPT, but LLMs are, at the end of the day, they're just, all they're doing is guessing the next word in a sentence. That's all they do. And somehow through just that process, we are able to generate code, write poems, like pretty much LLMs have been able to do all the amazing stuff only by guessing, not even the next word, but the next few letters of every sentence that it's generating. The catch with this is that it feels deceptively capable at doing a bunch of stuff, but it's usually really, I mean, pretty often you'll realize that it's really bad at doing math. It's pretty bad at thinking, reasoning and logic. Even though it's not that it can't do it, it's just that it needs a lot more effort to get it to do what we want it to do. And those are the general limitations that we've seen when we're trying to have reliable and repeatable results from LLMs. We are struggling to do that for math, for let's say complex system design, or even data science code, etc. One way that we have figured out to solve this is to think about LLMs as not as don't use it to do math, because we already have software and like computers to do that. Just use it to figure out contextual decisions, like in the sense that we're using it kind of like an orchestrator, or like it's just uh, we build something like agents, like almost like human like agents, which have some sort of memory, some sort of tool usage. But the logic is that they, based on the questions that come in, they are able to understand the context in which they're asked, and then figure out what task to do next, or like what series of tasks to do after. uh, there we found like language models are exceptionally good at figuring out the series of steps to take to solve problems, because they can contextually make really good decisions. They might not be the best at doing the math, and therefore we delegate that task to the traditional softwares like cadCAD. So the cadCAD GPT, in some sense, is an integration of this orchestration layer of language models, uh, deciding what to do when a question is asked to it. So cadCAD is being used as the tool itself, and the agents that we talk about are like they plan and they execute things on the code, and the entire setup, the entire architecture that we built actually takes in questions and gives you answers using the tools that we built. Yeah.
Yeah, and I noticed that within the architecture of cadCAD GPT, we have these kind of two distinct agents. It's a planner agent and an executor agent,
Mm-hmm.
and these are kind of two different responses to the particular tasks or functions that they provide the system. And so you have a planner agent. What function does the planner agent provide the system, and how does it work?
Right. So I guess I could take a step back and maybe explain that. Okay, the agents themselves. The reason we have chosen this setup is that um, basically that maybe it's a current the current LLMs that we have they have really small context windows, or even if they have large context windows, it's not that easy to get them to do what we want to. So, a very high level structure that we figured out to solve the problem was you build these two agents. One agent, when a question comes in, like for example, hey, what would happen if my particular parameter was this? And can you plot the graph or something? If you have that kind of a data science question, the planner agent takes the question in. It it is aware of the tools that it has access to, and just makes a plan as to how many steps and what steps to take to get to the answer. And then the executor agent takes up the plan and then executes it one by one on the code itself. Uh, the reasoning behind this separation is slightly nuanced, but it comes down to like cognitive architectures that people have been thinking about since a very long time. Like this field has existed since way before LLMs, but we've almost rediscovered them while we were building complicated tools using language models. The bunch of architectures that are coming out, and this is the one that works for our use case the best. Um, the logic in these architectures is we want complex reasoning and tool usage and some sort of memory, and we want all these things that humans tend to be able to do in the data science role. We want them to be executed by language models now, but we can't use a simple base language model and just ask it a question and get an answer. We need to create these separation of tasks, almost like, in some sense, like a CPU, which plans and executes things on the tools it has access to. I think the best way to think about cadCAD GPT is like a CPU for, I guess, running complex system models and experimenting on them.
Yeah, and so with the planner agent, it provides I guess it's called a task list, and so that's just basically taking the input from the user through the chat system and actually saying, okay, here's how you solve it, and then the executor agent. What is the role of the executor agent compared to that?
Yeah, so the planner agent, you're right, it would just figure out the series of tasks that you need to series of steps you need to take in order to get to the answer, and the executor agent would be actually executing it on the code. The executor agent is built on this React framework, which basically means it reasons about the task, it takes an action on the task that it thought about, and then it observes the result. There is, again, like quite an interesting reasoning behind that too, but I guess the crux of it is that if you understand how Python functions work, planner agent just decides what functions to use when, and the executor agent decides what arguments to put into those functions. So we are separating these tasks in order to get LLMs to reliably work and repeatably work on the data science problems that we have. I guess on a level like planner agent is planning, executor agent is actually running the code and then observing the results and trying to interpret them. I think that's maybe the separation that you're thinking.
Yeah, that was a really good description of it, using the function and argument explanation. But the one thing that keeps coming to mind is like, how does do these agents have kind of this contextual knowledge for how these models work? I assume that when you put something into cadCAD GPT, it already assumes that you're working with a cadCAD model that you've already built and iterating on it. So how does the agents involved in this system have the contextual knowledge to actually interpret these results that they're getting from this simulation?
Right. So there's two places that I can get this information from. One place is the prompt itself, that we have actually told the agent what its task is, the context in which it exists, and like some of like it has a section called the memory, and the way you imagine memory is kind of like the knowledge that it has about the subject. Also, the short-term and long-term memory. So the short-term memory is the chat context. So like it's you've spoken to it, asked a bunch of questions, and it will remember the chat context of your previous conversations, or at least the results that it got from previous steps that it took. And the long-term memory is generally more about the stuff that you feed into it for a long-term context. Kind of like you could give it the documentation of the model, you could give it question like answers about or questions, answers, or even documents about whatever context you needed to know in the long run. It has access to that and uses a semantic search. So based on the question that you ask it, it's able to semantically retrieve a relevant section from the document and be able to then use it to reason about the answers. That's the section with the memory. Another place which is relevant to know, like when you're asking about the context question, is that tools themselves have a lot of context in them, because the second you add a tool to the toolkit of cadCAD GPT, you're supposed to give a description of the tool. Generally, we put it in the doc strings of a function. So you write in what context should the function be used. So you have some, like some description of what the tool is, and when it is used, what the input should be, what the output should be. This generally comes from reading the tools in the toolkit. So the description of the tools are extremely relevant for cadCAD GPT to know when to use it. Yeah.
Yeah, and so we have the two agents with their particular functions, the planner agent, the executor agent, and they're interacting with the user inputs from the prompts that they provide, as well as the long-term memory. So I just have one question about this kind of the memory part, because when you do have your own cadCAD model that you bring into the cadCAD GPT system, you are providing the documentation. Like, is there limitations to like what types of file types you can put in, or like what type of information you can give store in that long-term memory, or
Yeah.
is it like a certain format or standard?
Currently, like the text format, markdown format should work. I don't think there are any major limitations currently. I mean, like apart from the standard documents are generally in text or markdown, so I feel like we've only had those. Although we can very comfortably convert it to something like scraping a web page, or so having a URL link, but we don't have that yet. But it's not beyond the capability. It's just you have to point to certain text chunks or a text document for CAD-GPT to use it. Currently, the easiest way to do it is have a text file that you just place in. Yeah.
Yeah, gotcha. Okay, and so that's how they get the contextual knowledge. The agents get the contextual knowledge for interacting with the human.
Mm-hmm.
Now you mentioned toolkits. Is that a way to interact directly with the model, for these agents to interact directly with the model? And like, what are toolkits in general, and like, what are the function calling capabilities that they have?
Yeah, so the open source cadCAD GPT repo, like we have an entire section called toolkits, like a function, a folder in which like there's a bunch of functions, and these are standard Python functions through which the agents within the cadCAD GPT can uh, use and execute them when needed. All of these tools themselves are um, like they themselves have a description. They are a Python function. They some of them can run the cadCAD model itself. Some of them are agents in themselves, which again, like it can get complicated, but they are like specialized agents in the sense that if you ask for a plot and you say something like, hey, I want a plot of these two metrics, a scattered plot with these colors or something. If you say it just in natural language, someone has to interpret it and convert it into a Python code. And that's the Plotly agent doing it, which so it goes into the planner agent. Planner agent decides what tasks to do when, passes it to executor agent. Executor agent decides, okay, we need, because this task is something I can't do, I should pass it on to a tool, which is in the toolkit, which is the Plotly agent. Uh, the Plotly agent basically then converts it to Python code, which gets executed. You get the plot and it prints. The executor agent prints it out. So the entire process can seem very complicated because again, I'm going into the depths of like how these agents are interacting with each other, how they're communicating, how they are delegating tasks to each other. But at the core of it, tools themselves are just Python functions. And some Python functions can be more complicated, some can be easy to build. The standard version of the open source repo has a bunch of them. You can plot, you can plot any graph you want. You can run statistics, so you can actually do any kind of data science, filtering, sorting, statistical analysis of your uh, result of your cadCAD model. You can change parameters. You can fetch information about the model, etc. Like those things are pretty standard, but it's so easy to build new tools that I'm sure like everyone will start. Whoever's using it can pretty easily like add more tools to the toolbar. Yeah.
Yeah. So with the toolkit, like are these all embedded into the system itself, or like is this kind of like a modular thing where people can like add new functions and new tools to actually interpret the model that they're running?
Yeah, pretty much most things here are modular, especially the tools. So tools are especially built to be modular because for every, I mean, we have the standardized tools which generally everybody will use for most scenarios. But um, for a specific model that you built and you want a specific kind of tool, it's super easy to just add into it. You just write a Python function that does what you want it to do. give a description, and add it into the folder of the toolkit. And that basically will be made available to all the agents, and they'll be able to use the tools when needed.
Yeah, that's really interesting. I think, I can imagine people, some like token engineers, utilizing this and having kind of a core set of functions or tools within the toolkit that they can call upon for certain models that create like particular methods. I mean, do you see that kind of emerging naturally as more tools are added to the toolkit?
Yeah, I think Angela had a bunch of ideas here as to like how token engineers can come in. Maybe if you want to comment. Yeah.
Yeah, sure. So number one, yes, for sure. I can totally see that a token engineer has a standard set, maybe personally, or this is something that we see emerging in the total sector. Bunch of standard tools, like the apps that everybody has on your smartphone, standard things you use every day for your first steps in a token design or in an iteration on parameters that you always run. And then there are more case-related tools that might only be needed for a very particular question, for a very particular token design in a very particular situation, that still take a lot of efforts to build and are worth building. And then these tools, or there's a certain tool that only one community needs at a certain point in time. I remember the token hatch at TEC. And Nate, you have been part of this journey where the whole community was iterating on the parameter setting, like what should be the vesting time for the initial contributors in the token hatch, or what should be the initial token price, so that we define the reserve versus the tokens to be minted. So these have been really important questions, and we have been iterating in the community about these questions. And this, what we did back then, could be translated into tools on top of the TEC token model, and then the whole community could ask the LLM agents their questions and dig through the design and take conclusions on what the best design should be. And this is then tools who are relevant at a certain point in time for some particular questions that other communities might not have.
Yeah, I think that's really fascinating. Like even the collaborative process of understanding, like, and what we did with the token hatch was really, really interesting just to see how many people contributed, and then also what we decided was important, what were the metrics that were important, how we all slowly came to consensus on what the final parameters should be. And I think, like when we look at the toolkits, I find that really fascinating that we can just keep adding to the toolkits of this system, and possibly have like the emergence of best practices as a result of it. I was curious, like, do you see the evolution of toolkits being kind of the feature of this type of system?
Yeah, 100%. So when we started cadCAD GPT at TE Academy, I mean, the whole idea was, can we find something that not only helps us for a very particular project, and it's an interesting exercise. Our goal was rather, can we find something that helps the total sector, that is relevant for the token engineering sector as a whole? And for the, let's say, longer term perspective of what LLMs and cadCAD GPT can help unleash in terms of developing the sector is the following. So we have heard, okay, tools are modular. The whole idea of cadCAD GPT is modularity. So modular contributions as well, because this is meant to be a framework where many can contribute to, everybody's asked to and able to add tools. There could be even monetization of these tools. Everybody's able to add memory. Projects can provide their system models, so their mechanism design. Again, Gitcoin grants is a great example. We have quadratic funding. We have again and again iterations also on quadratic funding, on making it Sybil resistant. So communities like Gitcoin can provide the system model with the most up-to-date algorithms available so that people and communities can find out how to utilize it and how to shape quadratic funding. Again, TEC is such a great case because we have tunable quadratic funding. You have built your own variant with some tweaks in how contributions in the Gitcoin grants rounds are translated to the ultimate results. And in this context, cadCAD GPT is like the platform to make all these contributions that are necessary to build these token systems, make this modular and more open. Some examples. If a community defines the terms of a token sale and token launch, this is basically startup investments questions. It's not so much about sophisticated incentives at this point. It's like comparing various token sales terms and see what the outcome might be and the token distribution might be. And this needs expertise from startup investments, and it needs data to benchmark your terms against the others in the sector to find out if this is compatible. So it's one stage of crypto project and needs a particular expertise: investment, VC, startups, token distribution. Then some time later, building token incentives to grow the ecosystem, to attract users, and also to align incentives of these users is a different task. It's much more strategical. It refers to product development, business models, understanding your stakeholders. And this needs a different type of expertise. Then later, further down the road, building a monitoring system for a token economy, assessing if it's healthy and growing, or if there are malicious activities, needs data science, it needs analysis of what's going on, it needs ideally real-time data and observing the right data. And it's again a very different task. And this is all needed in the life cycle of a token economy. Now, cadCAD GPT is the platform to provide interfaces for these different tools that are needed at a certain point in time to run simulations. And these tools can be built by various experts and can be added by various experts. And this is what we need to develop the token engineering sector. Modular contributions from people with a very particular and deep understanding of their field. Because at the moment, today, what's challenging for projects, it's a little bit like the early stage of Web 2. You try to hire one token engineer, and this token engineer should cover everything from a token launch to the design of token incentives to monitoring and securing the system. And it's just not doable to have this all in one person. It will be rather that you take in the expertise of various domains to address particular questions in the life cycle of token economies. And frameworks like cadCAD GPT makes it easier to integrate tools that are useful at a certain point in time for addressing certain questions. And this way also allows different experts to come in, add their expertise, and make it accessible to the users.
Yeah, that's really awesome. Like it's one of those things where you putting it into the perspective of the different domains of knowledge that needed to be understood within the token engineering process, and from the birth of a token economy to its maturity, having this embedded within a modeling system I guess my big question is that do you see the by lowering the barrier to access through the cadCAD GPT to utilizing these models, that you'd be able to build up a kind of a modeled library of these different domains, and to find kind of best practices in terms of each of these specific areas or stages within economic development?
Yeah, for sure. I would call it's rather a tool and memory library and not so much a model library. But ultimately, both is feasible. I guess when I refer to the different questions to address, it's rather the tools. So what are the tools to address a certain question based on token economy that defines the model? But it's certainly, this is the route to take. Having libraries, having best practices, also having competition on. I mean, imagine you could test various approaches, various tool sets to monitor your system and find out what works best. Or you could even run several and combine several from different experts, different approaches, and combine it for the best of the system. This would be awesome.
Yeah, and I guess this is a good point to ask you both, if you don't mind answering this question, is that what are the things that excite you most about cadCAD GPT's potential use or future use? Like, is
Rohan,
there
you
anything
go first. I take it
yeah.
the second round.
I mean, I guess mine would be more. I wear my researcher hat when I play around with these tools. So for me, it's so fascinating to see how agents can delegate tasks, talk to each other, communicate with each other. I think I find that super fascinating to see how you can build reasoning skills, combining software and language models. I think for me, it's a bunch, like how can we think about like a better cognitive architecture through which we can make these kind of tasks more easier to do, and like solve even like harder and harder problems. I think to me all that is super fascinating. That's the direction where I am most excited. I feel like also in terms of the fact that I would really love that all these models that people are building using cadCAD, I would love that others who cannot run Python or don't know about cadCAD, um, they the tools shouldn't stop them from being able to at least ask questions to the simulations and experiments we are building. So being able to make a very easy interface to all the models that you build. You don't have to build an entire website or a front end. You can just use cadCAD GPT to start asking questions, and it gives you the answers of different kinds of scenarios you want to test yourself without having knowing Python. I think that is the most fascinating part for me. Those 2 points. Yeah. Angela, if you want to take up.
Yeah, I fully agree, Rohan. This is super fascinating. I would maybe add, okay, interacting with LLMs is just a very new way to interact with computers. And even for us, after months of working with the LLM agents, it's fascinating again and again to sit in front of your laptop and just start asking cadCAD what if the token distribution starts earlier? What's the benefit compared? Just such a very general human style question. And you get a result, and this result is spot on. This is just so fascinating, and this is the moment that to me is like, okay, now we are getting to the point where we have the human perspective, and you are not forced as a human anymore to translate it to computational language yourself. You can directly interact with computers and get a result. And this is a moment where I say, now we have this fusion of machine and human intelligence, and seeing that we are just at the start of leveraging the potential of token economies. I mean, what we are currently doing in terms of incentive design is very, very early. It's very, very simplistic. It can be so much more. If you ever went a little bit into game theory, for example, voting mechanisms, They are all gameable. If you try to make them robust, they very quickly get very unintuitive for human beings. And this is like a barrier we have to overcome for decentralized governance. And LLMs can just help us in overcoming this barrier and unleash the full potential of it. And this makes me so excited about LLMs.
Yeah, I'm really excited about cadCAD GPT. When I first heard about it, I got really excited and giddy about it. I've got one last question for you, but before I do that, I want to make sure that anybody in the audience, if you do have a question for any of our guests, please do raise your hand, request to speak. I'd love to have you up here to ask a question. Yeah, don't hesitate, please. But my last question for you guys is, are there any challenges that are evident to you that kind of you see as being an obstacle to the continued success of the project? Like, are there anything that's about cadCAD GPT that you wish you had more certainty about, or yeah, just in general, what do you see as being the biggest obstacles to its success?
I would say let's talk a little bit about plans and next steps. So what we now definitely want to see is applied to apply cadCAD to real world cases. So in case you are interested to try it out, you have a great case, reach out to us. We'd like to prove the value of it and want to collaborate with a handful of projects. This is first angle. And the second one is, okay, we talked a lot about building the model as a prerequisite to then apply the tools and memory. Building models itself is another one. Maybe Rohan, you'd like to add some more words here on next steps on this front.
I guess like a bunch of like tools that need to be added would be really cool, because I feel like once we get real world cases and actually start working with varied models, I think we'll understand what are the standard set of routines of tests or experiments that people run, and then convert them to tools. So I feel like, yeah, I would echo the same thing, that I think real world projects and being able to work with teams that actually using cadCAD would be really cool to push this forward.
Yeah, and so if we have any audience questions, please do request to speak. But I was going to ask one more additional question: is that what is the current state of development with cadCAD GPT, and is there like what are your greatest needs, and is there anything that the token engineering community can do to support you in this effort?
I mean, building tools is an interesting one. We have published 3 articles. I think it's already pretty easy to Google cadCAD GPT. There's the open source repository and 3 articles on Miro where we list the most important new tools that we'd like to see that would be generally relevant for any token engineer, and also some fundamental research questions that probably require some basic research on cognitive models, maybe even on how to support in the modeling process. So there's definitely a lot to do, and a super exciting environment to for data scientists, for engineers, in this case systems engineers, to add their skills. And certainly also for people who are interested in improving governance processes to see, okay, because again, stakeholders in DAO decision making are certainly one of the user groups we have in mind for cadCAD GPT. What are the typical questions to explore? Are there any cases? Let's take a look at the front end. What is a super easy, intuitive way to interact with these LLMs, and how to make this the UX super user friendly.
Also, on the development front, I would add that the pace at which language models are moving, the pace at which OpenAI keeps changing stuff, I feel like it would be really nice to have open source language models running this instead of using like like OpenAI's language models. And so even that direction of development will be very interesting to see open source language models being used so that we can host it ourselves and we don't need to keep changing stuff as OpenAI changes its code base.
Brings us back to public goods. cadCAD GPT is a public good. Ideally, we connect it to LLMs that are public goods and help crypto overall.
Yeah, well, the Token Engineering Commons is a huge supporter of everything you guys have been doing, Token Engineering Academy and at Block Science.
100%.
It's been really amazing to talk to you both today about this. cadCAD GPT, if you're a token engineer, please do reach out to Angela or Rohan to get involved, start building some models, start using the tools, test everything out, just get in there. But I do want to thank you both for joining me today and everybody in the audience for joining us and learning a little bit more about cadCAD GPT and a new era of token engineering, in my opinion. So really thank you both for joining us, and just so glad to have you here.
Yeah, thank you so much, Nate. And
thanks, Nate.
Yeah, thanks for the conversation.
Yeah, absolutely. It was great pleasure. Thanks for having us, Nate, today.
Yeah, no worries. I hope you have a good rest of the day.
Same to you.
All right, bye, everybody.
Bye. Thanks for coming.
Bye.